In this lecture, I'm going to give you an overview of the world partition system, which is an optimization system that solves the memory and performance issues that arise when trying to create huge levels. And having a huge level is generally a necessity if you're trying to create an open world for your game. In gaming, an open world refers to a game mechanic in which players are free to explore a virtual world without barriers, and to choose which objectives to attempt next, as opposed to a game that has a more linear and structured gameplay. And so a common feature of these types of games is that they usually contain a huge outdoor area that the player can walk around freely and seamlessly without loading times. So for example, huge landscape terrains like the ones we've been developing, or like the ones in popular game series such as Elder Scrolls, Fallout, and Zelda. Or the open world could take the form of a large city, like in series such as Grand Theft Auto. Regardless of the setting or theme, however, any very large level creates a difficult problem for the developer. Every PC and console only has so much memory available to store game assets, and only so much processing power to render those assets and calculate their physics, and so on. The typical solution to this problem is to divide a game into levels, and only load the assets needed for the current level. And so the player can walk around the level seamlessly, and there will only be loading times when loading a new level. And so this works fine most of the time. However, open worlds are usually way too large to store memory all at once. And yet the player expects to be able to walk around seamlessly, just like a regular level. So to achieve open worlds, a system is needed to only load the area around the player at any given time, while leaving the rest of the world unloaded, and then to load and unload assets as the player moves around. In Unreal Engine 4, this was accomplished using the world composition system. Under this system, large levels were composed of several smaller sublevels, which then had to be streamed in and out manually using level streaming. But in Unreal Engine 5, with the new world partition system, the entire world will be stored in a single persistent level, which is automatically divided into grid cells. Those cells are then automatically streamed in and out based on their distance from a designated streaming source, usually the player. Alright, so there are three different ways to enable the world partition system for a level. One way is to create a new project using one of the templates in the games category. The default level for each of these projects has world partition enabled by default. They do not, however, have grid cell streaming enabled by default. So to enable that, you would need to go to Window, World Settings to view the World Settings panel. And then in the World Partition category, you would need to set the Enable Streaming property to True. Okay, so a second way to enable the world partition system is to create a new level using either the Open World template or the Empty Open World template. Both of these levels start out using world partition and have enable streaming set to true. The open world template also includes a 2x2 kilometer sample landscape and an outdoor lighting setup. And then the third way is to take an existing level and convert it to a world partition level. So to do that, I'm going to go up to the menu bar and then to Tools, Convert Level. Then I'm going to select the level I wish to convert, which is the level I currently have open, and click on the Open button. This will open a dialog box where I can adjust the settings of the conversion. The most important setting is in place. By setting this to true, the converted level will overwrite the original level. However, it's highly recommended to leave this set to the default value of false, so that if there's ever a problem with the conversion, you don't lose the original copy. Okay, so once I've finished with these settings, I can click the OK button to continue. So then the converted level will have _WP appended to the original name, and it will open automatically and will include a world partition and have enable streaming set to true. And then to open the world partition window, I just need to go to Window, World Partition Editor. And so this window will display a mini-map of the level with the partition grid that was generated overlaid on top. However, this will start out at a scale of 32 by 32 kilometers, so I will have to zoom in first to see anything, which I can do using the scroll wheel of the mouse. Okay, and then this gray square here is my landscape actor. So even when actors are unloaded and invisible in the editor, as my landscape actor currently is, as long as this show actors property is checked, the actors will be visible in the world partition window. Alright, so as I mentioned earlier, the world partition system works by dividing the level into grid cells that are loaded and unloaded. In order to visualize these cells, I can set this show cell coordinates property to true. And then if I still don't see the cell coordinates, it means I'm still zoomed out too far. So I'm going to zoom in some more until I see them. Okay, so now we can see where the individual grid cells are. So if we look closely, we can see that the landscape actor covers a 4x4 grid of cells. And so when a grid cell is loaded, this means that all of the actors within that grid cell are loaded. But what use is this for a landscape actor, which is just one large actor? To solve this issue, whenever a landscape is added to a world partition level, or whenever a level with a landscape is converted to a world partition level, the landscape will be automatically subdivided into units called streaming proxies. So if I go up to the outliner and find the landscape actor, and then expand it, we can see that this landscape has been divided into 4 different streaming proxies. So each of these 4 quadrants of the landscape is its own streaming proxy. So for the purposes of the world partition system, each of these proxies will behave like individual actors and will load and unload individually. And so this allows landscape actors to take advantage of the benefits of the world partition system as well. Alright, so the world partition system is not only for saving memory and improving performance when playing the level, but also when editing the level. In both cases, the visibility of actors within the grid cells is primarily based upon the loading and unloading of the cells. In the case of editing, this is done manually by the user based on the area of the level they want to work in. So when a level is first converted, all of its grid cells will start out unloaded. And that's why my landscape is currently invisible in the editor. So first, I'm going to turn show cell coordinates back off to reduce the clutter. And then I'm going to left click and drag to select the region around the upper left grid cell. And then I'm going to right click and select load region from selection. And now, any actor that overlaps with the loaded grid cell will be visible in the editor. In this case, it is this landscape streaming proxy. And now, if I want to quickly travel to this location in the editor so I can work on it, I can right click and select Move Camera Here. Or simply double click and I'll be taken straight there. Okay, and now I'm going to turn up the camera speed and adjust the view to try and get a bird's eye view of the entire landscape, similar to what we see in the world partition window. So now, if I select any region in this quadrant of the landscape and right click and select load region from selection, it will load this streaming proxy. Okay, and then to unload cells, I just need to left click on the selection I want to unload, then right click again and choose unload selected regions. Alright, so that's how the loading and unloading of cells works in the editor. Now let's take a look at how it works during runtime. But first, because only 4 streaming proxies isn't ideal for this demonstration, I'm going to create a new level and use a new landscape. So I'm going to create a new level based on the basic template. Then I'm going to delete this floor and then save the level. And now I'm going to go to the Tools menu, select Convert Level, select this level, then click OK, and then OK again. Okay, so now this is a world partition level. Alright, so now I'm going to switch to landscape mode. And because I am now creating a landscape in a level that is already a world partition level, the new landscape tool will have this one additional property, world partition grid size. What's great about this property is that we can use it to specify how many streaming proxies this landscape should be divided into. So I'm going to zoom out until we can see the entire landscape. So the way this world partition grid size property works is that it sets the number of components there should be along a single axis per streaming proxy. But it won't change the number of components to make the math work, it will change the number of streaming proxies. Okay, so these yellow lines represent the outlines of the streaming proxies. So with world partition grid size set to 2, each streaming proxy will be made up of a 2x2 grid of components. And because this landscape is an 8x8 grid of components overall, it will be divided into 4 streaming proxies along each axis. If I were to change this property to 4, each streaming proxy would be a 4x4 grid of components, and thus there will only be 2 streaming proxies along each axis, just like in the previous example. Okay, but I'm going to set this property to 1 so that there will be just 1 streaming proxy per component, which will create 8 streaming proxies in each direction. Okay, and now I'm going to click the Create button. Alright, so now if I go to the outliner and expand the landscape actor, we can see that because there are 8 streaming proxies in each direction, this has divided the landscape into 64 total streaming proxies. And now I want to set the landscape's material, but in order to do that, I will need to apply it not just to the landscape actor, but to all of its streaming proxies as well. So I'm going to select the landscape in the outliner, then scroll down to the final streaming proxy. Hold down the Shift key and then click on the proxy, and that will select it and all of the other proxies in between. And now I can go to the Details panel and set the landscape material and landscape hole material, and it will apply to all of them. And now I just need to click over to Paint mode and set the layer info objects for each of the material layers. Okay, so now I'm going to click over to Sculpt mode and just do a little basic sculpting to give this landscape some distinctive features which will help the demonstrations. In particular, I want a few really tall mountains at the edges of the landscape. And now I'm going to zoom in to the center of the surface of the landscape. Switch back to the selection mode and add a player start actor so that I will start out in the same place in the middle of the landscape every time I run the game from now on. And then I'm going to do another save all. Alright, so finally, we are now ready to take a look at how the world partition system works during runtime. In part 2 of the World Partition Overview lecture. Ha 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 ha, cliffhanger.